All right, hello grade 9s. So this week is going to be a fairly short one in terms of new stuff. There isn't any new stuff. Today we have review, and I'm going to go through sort of the basics and then leave you with some questions. And then tomorrow, so Tuesday morning, I'll post the solutions to everything. And then Wednesday, I'm going to post the unit test. Okay, the important thing for the unit test is that a right answer for most of the questions with no work isn't really going to be worth much. If it's a 4-mark question, you'll get 1 mark for an answer. So I'm going to need you to figure out a way to show your work. Whether you're typing it, which I don't really recommend, I would recommend writing it on a piece of paper. And if you just write it on the paper and you don't have the question because you don't have a printer, that's totally fine. I just want you to show me your work, and you'll take pictures of it and submit it with the test. So there'll be questions on the test that are just attach your work, and that's all it'll be, and then I'll be looking at those. Okay, so let's get into the review part. I want to make this quick. So there's sort of 3 parts in this unit. The first part was scatter plots. So down here we have the independent variable, and this is often something like time, or number of people, or distance traveled, or number of items, stuff like that. It's also our x values. And then up the side here, this is where our dependent variable goes. That's often cost. It could be, sorry, down here would be time, not distance. Distance traveled would be up the side, and these are our y values. Okay, so this goes with your handout, so you can follow along however you like. And then we have distance time graphs, okay? And distance time graphs, what we usually do is we put points at each of the parts. And then what I've been doing is I've been labeling them sections A, B, C, D, and E, okay? And what you're going to have to do with these is determine the time, the distance, and the speed in each section. So A, B, C, D, and E. I'm just going to do A and B. I'm going to leave C, D, and E for you, and I'll post the answers tomorrow. So to find the time in section A, we started at 0, we finished at 4, so it's going to be 4 minutes. To do the distance, we started at 400 meters from home. And up here, if we go over to the y-axis, we finish at 600. So to find the distance, you would do 600 minus where you started, which is 400, and that's going to be 200 meters. To get the speed, which I'm going to call S, we do the distance, 200 meters, divided by the time, which is 4 minutes. You can also think about it as doing the rise divided by the run, and we would get 50 meters per minute. And if I asked you for the direction of travel, if the line's going up, like this one is, it's going away from home. If it's going down, like C, it would be towards home. Section B. So this is where it gets a little bit tricky for the time, because now we start at 4 and we finish at 7. So to get the time, 7 minus 4 is going to be 3 minutes. Now the distance traveled couldn't be easier. If it's a flat line, you go 0 meters. And the speed is going to be 0 meters divided by 3 minutes. But obviously you already know a flat line is 0 meters per minute. The speed is 0. I would like you to do C, D, and E. I'll post the answers tomorrow. All right. Part 3, rates of change in initial values. It costs $25 to have this clown, which everyone wants a clown for their birthday, obviously. They're not creepy or anything. It costs $25 to have a clown come to your house, and additionally, $15 for every hour that the clown is there. So we need the initial value. We need the rate of change and the equation. Now, in a word problem, you folks have been getting this no problem. The initial value here is obviously the 25 bucks. The rate of change is going to be the for every number, or per number if it says per, and that's $15. We need two units here. $15 per, and it looks like it goes up per hour. And the equation is going to be C equals, because it's cost. Remember, these equations always look like y equals mx plus b. And then the m is the rate of change, so 15. The x is going to be the other variable, so h for number of hours. A lot of you are using little n's, and that's fine. And then plus b, b is the initial value, so plus 25. And you folks have been doing really well with this, so I'm not going to spend too much time on that. Okay, the second part of this is from a graph. So just to help you out here, the initial value is going to be here. Okay, so it's going to be 5, and the units, well, does 5 meters make sense for a bean plan, or 5 centimeters? Probably 5 centimeters. To get the rate of change, you're going to pick 2 points. I'm going to pick 2 points that are really far away from each other, because why not? It doesn't make a difference. Ugh. And I'm going to do the rise and the run. Okay, so to find the rise, we go from 5 all the way up to 14. So the rise, we're going to do 14 minus 5. We're going to get 9. And to get the run, we do the x value for the second point, which is 3, minus the x value of the first point, which is 0, and we get 3. The rate of change is the rise over the run, and it's going to be 9 divided by 3, which is 3. And for the equation, well, instead of c for cost, we can see that our y value, our dependent variable, is h equals, remember, it's y equals mx plus b. M is the rate of change, which is 3. X is this axis, so days of sunlight, so I could say d for number of days, or little n for number, and then plus the initial value, which is 5. Okay? The last one, I believe. Oh, no, sorry, not the last one. Direct and partial variation. So, direct variation is a linear relationship that starts at 0, not zero. And a partial variation is a linear relationship that does not start at 0. Okay. So Student Council is thinking of offering 2 new payment plans for school dances. Write an equation for each. So this will be number 1, this will be number 2. You can pay $4 per dance. So whenever you see for each or per or anything, we know that that's the rate of change. So the cost is 4x, but in this case, our independent variable is the number of dances. So I'm going to say 4D for dance, plus the initial value. Well, they didn't say the initial value, so that must mean it's plus 0. But remember, if it's plus 0, you don't have to write it. Number 2, or you can pay, so cost equals 6 for an annual pass and 2 at each. So again, that at each tells us that's the rate of change. So 2, again, we use the same variables, plus, and what's the initial value? Well, it costs $6. Okay, and what I want you to note here is that this is direct because it starts at 0, and this is partial because it starts at 6, which is not 0. Okay, that's it. That is the note for today. So all that I have for you, I want you to figure out the rest of this, C, D, and E. I did this question, I did this question, I did this question. All that's left is for you to do these 4 EQAO questions that I took from previous years. And again, the answers will be posted tomorrow morning. So please give them a shot. Reach out to me. We can do a Google Meet. I can call you on the phone. I could record a video of me doing something that you're having trouble with and post it or send it to you. So there's lots of options to get help. So please make sure that you do. Okay, folks. And then at the end of the lesson here, I had a big thing that said study. And remember, studying for math just means go back and try some of the examples again. Right? Cover up the answers, make sure you know everything, and again, reach out if you have any questions. Okay, good luck, folks.